Hello, today we're going to be talking about particle classification. The first thing we're going to do is we're going to classify some known particles into their respective groups. We're then going to meet something called a quantum number and talk about how these different quantum numbers are associated with these different groups. And finally, we're going to meet a couple of new particles, the pion and kaon, and classify them. To start with, we can classify all of the particles we know about into two major groups, the leptons and the hadrons. An example of a lepton that we know is an electron. Similarly, two examples of hadrons that we know are the proton and the neutron. The proton and neutron can be further subdivided into a class of the hadrons called the baryons. Baryons are particles that are made up of three subparticles called quarks. These quarks are held together by the strong nuclear force. They have a special quantum number associated with them called the baryon number. The only stable baryon is the proton. Every other baryon will eventually decay into a proton. For example, a free neutron will decay into a proton in roughly 10 minutes. All of the baryons have a baryon number of +1. It's also worth mentioning that the antiparticles of the proton and neutron have a baryon number of -1. Leptons are the other class of particle we should know about. Leptons are fundamental particles. That is, they're not made of anything smaller. Importantly, leptons do not feel the strong nuclear force. They also have their own quantum number called the lepton number. The other type of lepton we should know about is the muon. Muons are very similar to electrons, except they are much more massive. The muon, for example, also has a negative charge. There are two different quantum numbers we need to classify these particles. The muon lepton number is associated with muons, and the electron lepton number is associated with electrons. The other type of particle we've already met, which is also a lepton, is the neutrino. We have a neutrino associated with each of these different particles. There's the electron neutrino and the muon neutrino. Each of these particles has a corresponding antiparticle. So for every lepton, there is also an antilepton. The charge of each of these particles is the opposite of the original particle, and each of these has a quantum number opposite of the original. Take some time now to pause the video and reflect on what you think the charge and the lepton numbers are for each of these particles. And here's the completed table. All of these quantities will be specified on the datasheet which you will have in the exam. The last group of particles we should know about are the meson. These contain two different varieties of meson, the pi meson and the k meson, that is the pions and the kaons. Every meson is made up of a quark and an antiquark. For example, a negative pi meson is made up of a down quark and an anti-up quark. We will cover these quark constituents in a lot more detail in a future lesson. As discussed, mesons come in two different varieties, the pi mesons and the k mesons. There are in fact 6 different mesons we should be aware of: pi plus, pi minus, pi 0, k plus, k minus, k0. As a last question, pause the video and have a look to see if you can classify all of these particles into their correct groupings. Some of these particles will fit into more than one group. And finally, here are the answers.